Hello everyone. What we'd like to do in this video is talk about the half-angle formulas. Okay, you'll find that these half-angle formulas are a direct consequence of the power-reducing formulas we saw in the last video. So let's first derive them. Half-angle formulas. Okay. So we saw that the cosine squared of x was the same thing as 1/2 times a 1 plus the cosine of 2x. And we also have that sine squared of x is equal to 1/2 times 1 minus cosine of 2x. So to derive the half-angle formulas, all we're going to do is make a substitution. Okay. Let's say x, or let's let x be the same thing as some angle divided by 2. So we're replacing x with theta over 2. So I guess, well, whatever theta is, whatever it is, you would just divide it by 2 and you get out x. Or whatever theta is, it's 2 times x. So if we make this replacement, we're going to get that cosine squared of theta over 2 is going to be equal to 1/2 times a 1 plus cosine. Well, now if I replace x with theta over 2, the thetas would cancel and we'll just get a 1 plus cosine of theta. Similarly, we'll have that sine squared of theta over 2 will be equal to 1/2 times a 1 minus the cosine of theta. So to get the half-angle formulas, now we're just going to square root both sides. So we'll have that the cosine of theta over 2 is equal to, this is going to be the plus or minus. Now I usually like to leave the 1/2 out front, but I think in the book they divide 1 plus cosine of theta by 2. Either way would be fine. Maybe I'll just leave the 1/2 out front. And we'll have a 1 plus the cosine of theta. Notice that I did a plus or minus here. We'll talk about that in just a second. And we also have that sine of theta over 2 is equal to the plus or minus the square root of 1/2 times a 1 minus the cosine of theta. Okay. So these are the half-angle formulas. An angle divided by 2. And what's great about these formulas is that we have an angle divided by 2, but in the formula we just have a cosine of theta. Similar over here, we have an angle divided by 2, but in the formula we just have a cosine of theta. So now a question is about how to choose the plus or minus, and this is something we'll always have to be careful about when using these formulas. The plus or minus depends on what quadrant. What quadrant theta over 2 is. I'm wondering whether cosine of theta over 2 is positive or negative. That completely depends on where this angle lives. So we want to know where theta over 2 is. So plus or minus depends on what quadrant theta over 2 is in. Okay, and here they are. So this is the key thing. This is the key thing to have written down. Again, okay, do I have these memorized? No. I just know that these formulas exist, and if I wanted to, I could probably rederive them. But if I'm ever going to use these, I just know they exist. We'll use our book, we'll look in the back, we'll look up these formulas. There's also a half-angle formula for tangents. You can look that one up. Oftentimes, if I'm using the half-angle formula of tangents, I'm just going to remember that tangent is sine over cosine. Okay, so let's just do some exercises with using these. Okay. So for example, these half-angle formulas can help us evaluate sines and cosines at kind of some awkward angles. So let's say we want to evaluate. Let's say we wanted to evaluate the cosine of 112.5 degrees. Okay, the thing to notice here is this is not something that's on the unit circle. However, what we can do is, let's say, take 112.5 degrees, and let's just use the best trick in the math book, and let's multiply this by 2 over 2. So 112.5 times 2, what is that going to give us? That's going to give us 225 all over 2. So what's nice here is actually 225 degrees is a nice number on the unit circle. So that's what we're going to do. We're going to write this. This is equivalent to, maybe I'll write it right here. This is equivalent to the cosine of 225 degrees all over 2. Okay. So what we want to do now is we want to use the half-angle formula. So let's recall what it says. Maybe I'll write it over here. The cosine of theta over 2 is equal to the plus or minus square root a 1/2 times a 1 plus the cosine of theta. Okay. So let's think to ourselves, when we're using this formula, we'll have to think about whether to choose the plus or minus. So we have to ask ourselves the question, what quadrant 225 divided by 2 is? What quadrant is that in? Or what quadrant is 112.5 in? Well, I hope you believe that 112.5 degrees, I hope you believe that this is in between 90 degrees and 180 degrees. So we're in quadrant 2. We're in quadrant 2. So should I choose the plus or should we choose the minus? Well, cosine is negative in quadrant 2, so we'll want to choose the negative version. So we're going to have a negative. We'll get the square root. We'll have a 1/2. And then we'll have a 1 plus. Now we'll have the cosine, not of 112.5 degrees, but just the cosine of 225 degrees. Times the cosine of 225 degrees. Okay. So now we know what cosine of 225 degrees is, or at least we can figure it out on the unit circle. Okay. 225 degrees, well, that's a multiple of 45. How many times does 45 go under 225? I don't know, we could use our calculator. 225 divided by 45 goes in 5 times. I think you could also think that this is 180 plus another 45. If you want to think we're actually here on the unit circle, or we could just draw it. So 1, 2, 3, 4. We need to do 5 increments of 45 degrees. So we're here on the unit circle. So this is 225 degrees. Okay, well, if we think about the reference angle here would be, what, 45 degrees. So what is the sine and cosine of 45 degrees? Root 2 over 2 and root 2 over 2. So we'll have root 2 over 2 and root 2 over 2. Okay, but we're in quadrant 3. Sine and cosine are both negative in that quadrant. Okay. So, moving this over here, this is equivalent to the negative. We'll get the square root. Let's see, we'll have a 1/2. We'll have a 1 plus. Okay, cosine of 225 degrees, that's negative root 2 over 2. Negative root 2 all over 2. Okay, let's just clean this up a little bit, make it look a little bit nicer. So this is equivalent to a negative square root. Let's distribute in the 1/2. So we'll have a 1/2 plus, or how about a 1/2 minus the square root of 2 all over 4. So we'll see, what are we going to get? So instead of 1/2, how about we write 1/2 as how about 2/4? How about we write this as 2/4? So then we'll have the negative square root. We'll get a 2 minus root 2 all over 4. Okay, we can distribute the square root to the numerator and the denominator. So this is equivalent to a negative square root of 2 minus root 2 all over the square root of 4, which is 2. And this is the answer. This is the same thing as the cosine of 112.5 degrees. Okay, let's use our calculator. Let's check our answer. Let's check our answer. Okay, let's make sure we're in degree mode. Okay, I'm in degree mode. The cosine of 112.5. And then let's also calculate the negative square root of 2 minus the square root of 2 divided by 2. Take a look. The same answer. How fun. How fun. Cool. All right. So that's how we can use the half angle formula to do some evaluations of cosines and sines. Let's do another one. Let's do one that has to do with radians. I want you to try to evaluate sine of, how about 3 pi all over 8. Go ahead and pause the video and give this a shot. Okay, let's do it. What we would like to do is, since we're using the half angle formulas, is we'd like to think about somehow using sine of theta over 2, which is the plus or minus the square root of 1/2 times a 1 minus the cosine of theta. When I'm writing these formulas down in my head, I'm remembering that we got these from the power reducing formulas. Okay, well, you could think of this as theta over 2, but we could also think of this as the same thing as sine of 1/2 times theta. So these are equivalent. So instead of thinking about some sort of angle in radians divided by 2, we could think about it as 1/2 times some sort of a radian measure of an angle. Well, we could rewrite this as, how about the sine, let's factor out a half. This is the same thing as 1/2 times a 3 pi over 4. And what's great is 3 pi over 4 is a nice number on the unit circle. Okay, I'm going to go ahead and erase what I have here. All right, so let's use it. So this will be the same thing as, we'll guess plus or minus here in just a second. So the square root, it'll be a 1/2, and then it'll be a 1 minus the cosine of just the 3 pi over 4. 3 pi over 4. Okay, is it going to be a plus or is it going to be a minus? Well, we have to think about what quadrant 3 pi over 8 is in, because I really want to know, these things are equivalent. I need to know whether sine of 3 pi over 8 is positive or negative. Well, 3 pi over 8. Okay, well, I hope you believe, let's see, that this is in between. Let's see, this is going to be between, what, pi over 2. This is less than a half. And 0. Pi over 2 and 0. So we must be in quadrant 1. This is 3 over 8. If it was 4 over 8, that'd be 1/2. This is less than a half. We are in quadrant 1. Okay? Is sine positive or negative in quadrant 1? I think it's positive in quadrant 1. So we're going to choose the positive version. Okay. All right. So cosine of 3 pi over 4. Where are we? Let's move 3 increments of pi over 4. 1, 2, 3. So here we are. Okay, the reference angle again is going to be 45 degrees. Sine and cosine of 45 degrees. Okay, let's write, or I guess if we're using radians, so the reference angle would be pi over 4. So here's 3 pi over 4. The reference angle is pi over 4, root 2 over 2, and root 2 over 2. Okay, and we're in quadrant, this is in quadrant 2, so let's see, cosine is negative and sine is positive there. So this right here, this will be the same thing as, the square root. We'll have a 1/2, and we'll get a 1 minus, we want to do cosine, so we want the x-coordinate, so we'll have a negative root 2 over 2, close those parentheses. Okay, let's just clean this up a little bit. Okay, so this is going to be the same thing as the square root. We'll have a 1/2, a negative and negative, that's a positive, and we'll get a root 2 over 4. Okay, let's think of this as a 2/4. The 1/2 is the same as 2/4. So this is going to be the same thing if, we add across the, we have a common denominator, so 2 plus root 2 over 4. So we'll have the square root of 2 plus root 2 all over the square root of 4. The square root of 4 is 2. So here's our answer. This is sine of 3 pi over 8. Okay, let's use our calculator, check our answer. Okay, so let's see, the sine of 3 pi over 8. We better make sure that we're in radian mode now. Okay, and let's calculate the square root of 2 plus the second square root of 2, all divided by 2. And what do you know? What do you know? Same answer. How fun. All right. Let's do another exercise. Let's actually use let's do another problem. Let's say 2 different ways. Let's say we want to calculate the cosine. Let's say the cosine of 15 degrees. Now we've actually already done this. We've done this before. I think we used the addition formulas. We use the addition formulas, or maybe the subtraction formulas for cosine. But let's do it in both ways. Let's use let's use the addition or the subtraction formula for cosine, and let's also use the half angle formula. Let's do it in 2 different ways and see what we get. Okay, let's first maybe try to use the subtraction formula for cosine. So I think we could do what, 40, this is the same thing as 45 degrees minus 30 degrees. Okay, so this will be the same thing as the cosine of 45 times the cosine of 30 plus the sine of 45 and the sine of 30. So using the subtraction formula for cosine, okay, let's see what we get. Well, cosine of 45 degrees is root 2 over 2. So we'll have a root 2 over 2. See, cosine of 30 degrees is root 3 over 2. Plus sine of 45 degrees is root 2 over 2. And sine of 30 degrees will be root 1 over 2, or 1/2. Okay, so what we get here is, what is this? This is going to be root 6. This will be root 6 over 4 plus root 2 over 4. They'll have a common denominator, so this will all be over 4. So this is one way to do this problem. However, we could have thought about this in a different way. This is also equivalent to the cosine the cosine of, how about 30 degrees all over 2? So if we do the cosine of 30 degrees all over 2, okay, we're going to use the half angle formula now. Okay, so this will be plus or minus the square root. We'll have a 1/2, and then we'll get a 1 plus a cosine of 30 degrees. Cosine of 30 degrees. Okay, do we want to choose the plus or do we want to choose the minus? Well, 30 degrees over 2, or 15 degrees. 15 degrees is in quadrant 1. Cosine is positive in quadrant 1, so we'll choose the positive version. So this is the same thing as the square root of 1/2. This will be 1 plus, the cosine of 30 degrees is root 3 over 2. Root 3 over 2. Okay, so if we clean this up, let's see what we're going to get. This will be the square root. We'll get what, a 1/2 plus root 3 all over 4. Except let's make this a 2/4. So this will be the same thing as the square root of 2 plus root 3 all over the square root of 4 all over 2. So you might be looking at these and you might be saying, are these equivalent? Are these equivalent? They sure look funky. They sure look funky. Let's use our calculators to check. Are these the same? Are these the same? Okay. The square root of 6 plus the square root of 2, all divided by 4. Okay. Or we have the square root of 2 plus the square root of 3, all divided by 2. And what do you know? What do you know? They are the same. They are the same. Well, let's make sure they're both the same thing as cosine of 15. Cosine of 15 degrees. Let's make sure we're in degree mode. And if we do the cosine of 15, all three are equivalent. All three are equivalent. So this is kind of interesting about, like, you might be thinking to yourself, how could I make these the same? This is something that's kind of tricky. It's hard to kind of massage one to look like the other. There might be some nice tricks you can use. This is something that's called an embedded root. Notice that we have like roots within roots. So it's something that's called an embedded root. And there are techniques for reducing or kind of cleaning up things like this, but that's, for another day in another video. So I just wanted to do this example here, just saying that, hey, you could use kind of either of these tricks that we've learned so far. They may look like they're different, but, using your calculator, you can verify that these are equivalent. Fun. Okay. Specifically, this is the embedded root. All right, let's do one more exercise. Okay. Let's find the sine of x over 2, given that let's say, given that sine of x is equal to negative 3/5. And we also know, let's say that x is in, let's say x is in quadrant 3. Okay. Maybe go ahead and pause the video and see if you can solve this problem on your own. Okay, let's do it. So what this is screaming for us to do here is to use a half angle formula. So let's write it down. Okay, here we have that sine of x over 2 Well, that's equal to the plus or minus the square root. We'll have a 1/2, and we'll get what? A 1. We're going to get a 1 minus the cosine of x. So here's the half angle formula for sine. Okay, now we have to ask ourselves the question about what quadrant we're in. We have to be a little bit careful. We can't say, oh, x is in quadrant 3. X is in quadrant 3. Oh, sine is negative in that quadrant, so we should use the negative. We have to be very careful here. I choose the plus or not minus, not based on what quadrant x is in, but on what quadrant x over 2 is in. So we have to be a little bit careful here. Well, how can we figure out what quadrant x over 2 is in? Well, let's think about where x is. X is in quadrant 3. X is in quadrant 3. Okay, so x is over here in quadrant 3. Okay, what's right here? This is 180 degrees. And over here, this is what? 270 degrees. Or, this is what? This is pi radians, or this would be 3 pi over 2 radians. So either one you want to work in. So I know that x here is between, since x lives in quadrant 3, it's between, I don't know, how about we use radians? Pi to 3 pi over 2. But we want to know what quadrant x over 2 is in. So what can we do? We can multiply everything by a half. We can multiply everything by a half. So this is saying that x over 2 is going to be between pi over 2 is going to be between pi over 2 and what will this will be? This will be 3 pi over 4. Well, where's pi over 2? Here's pi over 2. Here's pi over 2. And 3 pi over 4. 1, 2, 3. Here's 3 pi over 4. So x over 2 lives here. X over 2, where are we? We're actually in quadrant 2. If x is in quadrant 3, then x divided by 2 is actually in quadrant 2. So we got to be a little bit careful with these sign choices. So if we're in quadrant 2, well, sine is positive here, so we actually want to choose the positive version. Okay. So don't rush through these problems. Take your time and really think about what's going on. Okay. So we have that sine of x is equal to negative 3/5. Okay. So we need to figure out what cosine is. So let's draw a triangle. Okay. Here's angle x. Okay. And let's draw a triangle. Let's pretend we're actually in quadrant 1, even though x is saying it's in quadrant 3. So this would be what? So sine is opposite over hypotenuse. This is a 3, 4, 5 triangle. So you could use the Pythagorean theorem and convince yourself that this length here should be 4. So we have that cosine of x is equal to adjacent over hypotenuse will be 4/5. Now, where do I choose a plus or minus? I have to pay attention that I'm thinking about x, not x over 2. X lives in quadrant 3. Is cosine positive or negative in quadrant 3? Well, cosine is negative in quadrant 3, so we'll need to put a negative here. Okay. I'll plug and chug from here. Let's write here that we know that cosine of x is equal to negative 4/5. So this will be the same thing as the square root of 1/2. And now we're going to get a 1 minus a negative 4/5. Okay, let's clean this up. This will be the square root. But we'll get a 1/2. We'll get a 1 plus a 4/5. How about instead of a 1, how about we write that 1 as a 5 over 5. So what are we going to get? We're going to get the square root. We'll get a 5 plus 4, so that's going to be 9/5, but I'm taking 9/5 and multiplying it by a half, so that'll be 9/10. So we want to clean this up. This is the same thing as the square root of 9 all over the square root of 10. Maybe bringing that up over here. This is the same thing as what? 3 is 3 root 10. It might be nice for us to rationalize the denominator, so let's hit this with a root 10 all over a root 10. So we'll get 3 root 10 all over 10. And here is our answer. What I'd like you to do now, we just found sine of x over 2. I want you to try to find cosine of x over 2 and also the tangent of x over 2. Go ahead and pause the video and give that a shot. Okay, let's do it. We just need to make a few adjustments here. Let's first find cosine of x over 2. Okay, so we'll want to actually have the cosine of x over 2. So the cosine of x over 2. Okay, keep that plus or minus there. Okay, now the only difference in the formula is there now be a plus here. Let's kind of keep our sine of x over 2. We found that was 3 root 10 over 10. Let's just keep that in our pocket. Let's keep that in our pocket. Okay. So now we just need to think, we had what quadrant was x over 2 in? We saw that x over 2 was in quadrant 2. Okay. Well, cosine is negative in quadrant 2, so we're going to want to choose the minus. So we'll choose the minus. So, and we also need to know what cosine of x was. Well, let's go back and draw the triangle we had up a second ago. So here was angle x, and what we had, this was 3 and this was 5, this was 4. So we'd have that the cosine of x is going to be equal to 4/5. Okay, but x is in quadrant 3, and cosine is negative in quadrant 3, so we'll need to put a negative here. Right? So we have the cosine of x over 2. That's going to be equal to the negative square root. The negative square root will have a 1/2, and now we're going to get a 1. Well, cosine of x is negative 4/5, so a minus 4/5. So we'll get a negative. We'll have the square root. Let's change this to a 5 over 5. So we'll get what? 5 minus 4, that'll be a 1/5. So 1/5 times a tenth. Sorry, 1/5 times a half is a tenth. I'm thinking too fast. This is the same thing as the negative. Well, it'll be the square root of 1 over the square root of 10. This will be 1 all over root 10. Let's hit that with a root 10 over 10. So we'll get that. We'll get negative root 10 all over 10. So we also have that cosine of x over 2 is equal to a negative root 10 over 10. Okay? So our next job is to try to figure out what tangent of x over 2 is. Okay, you could go ahead, you could look in the back of the book, you could look for the formula for the half angle formula for tangent, but I already know what sine and cosine are. So to figure out what tangent of x over 2 is, I'm just going to note that this is the same thing as sine of x over 2 all over the cosine of x over 2. So that's going to be what? 3 root 10 over 10 all over a negative root 10 over 10. So I guess you could flip and multiply. Let's flip and multiply. Sure. So this, what do we get? We get a 3 root 10 over 10 times what? A 10 all over negative root 10. Well, these 10s cancel. This root 10 cancels with this root 10. Looks like we just get out negative 3. So we have that tangent, we have that tangent of x over 2 is equal to -3. Okay. In terms of sine, S-I-G-N, this should make sense. We discovered that x over 2 is what? X over 2 was in quadrant 2. Okay? Well, sine is positive in quadrant 2. Look, sine is positive. Okay. Cosine is negative in quadrant 2. Look, cosine is negative. And also in quadrant 2, when we think about the slopes over here, the slopes are negative over here, so tangent is negative in quadrant 2. So at least based on sine, S-I-G-N, I'm pretty happy with these answers. Okay. This is the last that we're going to talk about of the half-angle formulas. What we're going to be doing in the next video or in the next couple sections is we're going to be solving trig equations. We'll see you there. Take care.